Okay, your do now says the amount of sugary beverages Americans consume is leading health concern. For a given brand of cola, a 12-ounce serving of cola contains about 40 grams of sugar. Complete the ratio table using the given ratio to find equivalent ratios. So we're starting with the ratio we were given, 12 to 40. We want to find one that's smaller and one that's larger. What's a smaller ratio that's equivalent, Unique?
6 to 20.
Sure, 6 to 20. You just divide it by 2? Excellent. I like this one too because I can just count by 6's on top and by what on the bottom? 20. Perfect. So 6, 12,
18,
20, 40.
60.
So exercise 3. Hillary, read exercise 3 for us.
A 1-liter bottle of cola contains approximately 34 fluid ounces. How many grams of sugar would be in 1-liter bottle of cola? Explain and show how to arrive at the solution.
Good. So a 1-liter bottle contains about 34 ounces. How much sugar would be in 34 ounces? Well, let's look at our table. We have 34 ounces on our table? No. Could we get there? Well, let's count by 6's and find out. 6, 12, 18.
24, 30, 36.
So I didn't get to 34, right? And on the bottom we counted by 20s, right? 20, 40, 60, 80. Okay, so even if I extend my table, I never found 34 ounces of cola. So do you think maybe there's a different way we could solve this problem? We're going to use a double number line. A double number line. So you're going to draw 2 number lines. And let's look at our table and decide where in our table would 34 ounces live. Juanita.
I want to say, like, there's one between the numbers that you have on the line. I want to say it's like
34 is between what 2 numbers in the table?
30 and 35.
Okay, what do I have on my table though? 30 and 36. Yeah, it's somewhere in here.
So it would be like,
Okay? So the number of grams of sugar in 34 ounces of cola is somewhere between here, right? Because they have to be directly across from each other to be an equivalent ratio. So between 100 and 120 grams, we'll find our answer, right? So let's use our number line to figure out exactly what the answer is. Because 34 is somewhere between 30 and 36, I'm going to put 30 and 36 on my number line. This number line represents what? April, what does this top number line represent? Kai? Yes. Ardanza? Ounces of? Yeah, ounces of cola. And what does the bottom number line represent? Unique? Sugar in grams. Just like the table, okay? We're just zooming in on part of our table. This part, 30 and 36. So across from 30, I need to write what, Gabriel? And across from 36, I need to write 120. Good. Now, let's find 34 on our number line, right? Because we can split it up any way we want to find whatever we need to find. We know 34 is between 30 and 36. Are there a ton of numbers between 30 and 36? No. Not really, right? Let's count. 30, 31, 32, 33, 34, 35, 36. So 34 is right here, right? I'm going to circle it because that's the value I know, and I want to find the corresponding value in the ratio. Okay, so when I use a double number line diagram, we always have to do whatever we've done on top to the bottom, or whatever we've done on bottom to the top. Okay? So what should I do down here? I drew 5 lines in between 30 and 36 here. What should I do on the bottom, Abram? Do the same thing. 1, 2, 3, 4, 5. And we need to line them up because think of it just like a table. When the numbers are lined up, they make a ratio, right? It's the same thing with our double number line diagram. So the number of grams of sugar in 34 ounces of cola is going to be directly below the 34 on our top number line. It's going to be whatever value is right here. We just got to find it, right? Now, this is the cool part. This is how we get to find it. Think of it. You don't have to draw it this way, okay? But I want you to think about it at first like a tape diagram. If it was a tape diagram, what would it be worth? What is the total that it would be worth, Alice? I can't hear you. Yes? So from here to here, what is all this worth? What amount? 20. How did you figure that out? Because she said 120 minus 100 is 20. So to get from 100 to 120, we got to add 20. This section is worth 20 grams of sugar. Now I need to find what number goes here. Okay, so how many parts did we divide our section into? 6, good. 6 parts. How many parts represent where this value lives? Well, 1, 2, 3, 4. 4 out of 6. So I can take 4/6 of what this section is worth and find out what these 4/6 are worth. 4/6 of what? 20. Is that the same thing as 4/6 times 20?
Yes.
Yup. Work it out. You have about 10 seconds. And what'd you get, Nathaniel?
86.
86. It's a hard word to say. Okay, can I rewrite this as a mixed number instead of this big improper fraction?
Yes.
Yep.
But wouldn't it confuse more?
No. So we just write 80 divided by 6. 6 goes into 8 once. 1 times 6 is 6 goes into 20 3 times, because 3 times 6 is, we have 2 left. 2 what? 2 6. Can I write 2 6 in a simpler way? Yes. How can I write it? 13 1/3. So 80 divided by 6 is 13 1/3. So this area that I've shaded from 100 to the value we want is worth 13 1/3 grams of sugar. So do I write 13 1/3 in the box?
No.
Why not? You're right. Tell me why. Why, Hillary?
Because it's a fraction.
So, I can't write a fraction on a number line? Alice? Yes. Because we did not start with 0, we started at 100. So we're adding 13 1/3, not to 0, but to, say it. Yes. 100 plus this part, 13 1/3, is what, Coral? 100 plus 13 1/3. What's 100 plus 13? 113. Plus, what am I forgetting about, my friend here? 1/3. What value goes here in the box? Isabella, what value goes here in the box? And 113 1/3. Okay, exercise 4. Read it for us, Amaya.
A school cafeteria has a restriction on the amount of sugary drinks available to students. Drinks may not have more than 25 grams of sugar. On this restriction, what is the largest size cola in ounces the cafeteria can offer the students?
So how much sugar can a student have in their drink in the cafeteria, Coral? 25 grams. And how many ounces of cola is that? We don't know, right? We don't know. What is the largest cola in ounces? That's what we have to find out, right? So we're going to draw our double number line. Because, is 25 in our table? Can we count by 20s to get to 25? No. So we're going to split it up. So between what two numbers in our table does 25 live? You can say it. 20 and 40, exactly. Somewhere in here. So what numbers do we write on our grams of sugar number line? Darlie? 20 and 40. Okay, we have to keep our ratios right across from each other, just like in a table. So what value goes here on our cola number line? Layla? When I have 6 grams of sugar, I have how much cola? I'm sorry. Oops, I just gave you the answer. When I have 12 grams of sugar, I have how much cola? When I have 20 grams of sugar, I have how much cola? 6, I'm sorry. And when I have 40 grams of sugar, I have how much cola? Unique. 12 ounces. So now I have my two ratios that I know the ratio I'm looking for is in between these two. Okay? What number do I know I need to find on the number line? You can read the problem again if you need to. Arlene, what number do I know I need to find? 25. What can I do to find 25 on my grams of sugar number line, Celeste N? I gotta find 25 in here. What can I do? I've got 20 and 40. Where would 25 be? Isabella?
Less than half.
Less than half. So let's start with half. What's halfway between 20 and 40? 30. And she says less than half. That's exactly right. Now we're going between 20 and 30. Where's 25?
In the middle.
Right in the middle, halfway. Good. Okay, I'm going to circle it because this is what we know we want. We want to find out how many ounces of cola contain 25 grams of sugar. We want to find out what number goes here. Whatever I do to the bottom, I have to do to the top, but oh, wait a moment. I have 3 parts, but they're not equal. How can I make my parts on the bottom number line equal parts? Isaiah?
You can divide the 30 between 30 and 40.
Exactly. Now I've divided the section between 20 and 40 into 1, 2, 3, 4 equal parts. I need to do the same on top. So I go straight up from 30, straight up from 35, and there's my 1, 2, 3, 4 equal parts. Now, like I said, we can think of it like a tape diagram. Let's just pretend there's a tape diagram right here. Okay? If that was a tape diagram, what would it be worth? Juanita?
The top one?
Mm-hmm. What would this area be worth? This section of the number line. How many ounces would that be worth? Turn and talk with your partner. Turn and talk with your partner. 10 seconds. How much is it worth and why? Okay, talk about it. Show me on your fingers what you think. How much is it worth? Show me on your finger. Oh, yeah. Yep. Yeah, it's worth 6. Why? Why is this section of the number line worth 6, Kai? Hands down. Hands down, please. Yes.
Science class where you have to subtract, I showed an example with Gabriel, what we did in science class, so it would be 2.5, and then it would be 8.5, and we subtract 8.5 minus 2.5.
Yes. You know what kind of thinking that is? That you just did, Kai? That's called interdisciplinary thinking. Does that sound like a big deal?
Yes.
It is a big deal. It is a big deal. It means you're taking concepts from math and you're relating it to concepts in science, and to you it may seem really easy and like, oh, this is just like we did in science. But the fact that your brain made those connections is awesome. So, good job. Okay. So now, I know this is worth a total of 6. I gotta figure out how many parts is worth. Well, my value that I want is right here. So how many parts do I need to find? Juanita? Woo. 1. 1 out of 4. 1/4 of what? 1/4 of 6. Work it out. You have 10 seconds. What did you get? Isaac Salceda, what'd you get? 2. You got 2? How'd you get 2? Kai. 24ths? Why did you multiply 6 times 4? Remember, think of it like this. Think of it like this. So what would be on the bottom, Kai? Columbia, give me 5. Sorry, Brown, give me 5. Hands down. I need to be able to hear, and so do you. Track, Kai. I know. Track, Kai. Kai, what is on the bottom now? 4 times 1 is... 4 times 1 is... Yes. Good. Can I reduce this?
Yes.
Aisha, how can I reduce it? By 2, and I would have 3 halves, or 3 over 2, right? Now, can I write this as a mixed number instead of an improper fraction? Yes. No, I mean, can I rewrite 3 halves as a mixed number? What's the same as 3 halves? I can take 1 out of there, right? Because 2 halves is 1. How many halves do I have left? 1. 1 and 1/2. Good. So do I write 1 and 1/2 right here? I'm getting mixed reactions. Thumbs up if I write 1 and 1/2 here. Hands down. Thumbs up if I write something else here. Adam, what do I write here? 7 and 1/2. Can you explain to us why? Exactly. I didn't start my number line, or this section that I'm looking for, at 0. I started at 6. So I have to add this section to 6. This is worth 1.5 ounces. So 6 plus 1.5 ounces is 7.5 ounces. Did we find our answer? Yes. Not yet, Isaac. Okay. Let's look at exercise 5. We're going to fill out the table together. You're going to work on part B with your partners. So, Chantel solves 3 math problems in 4 minutes. Well, I got 3 questions right here in my table. How many minutes does it take her? 4. I counted by 3's on top. What do I count by on bottom?
4.
Let's do it together. 4.
8, 12, 16, 20, 24, 28, 32, 36, 40.
Okay, let's read B together, and then I'm going to let you work on it with your partner. Chantel has soccer practice on Thursday evening. She has a half hour before practice to work on her math homework and talk to her friends. She has 20 math skill work questions for homework, and she wants to complete them before talking with her friends. How many minutes will Chantel have left after completing her math homework? After completing her math homework to talk to her friends. Use a double number line diagram to support your answer. So we have to draw our double number line diagram because the question asks us to. Now, she has 20 questions. Do we see 20 on our table?
Yes. No, we don't.
We do, but where is it?
Not the right.
Minutes. We have 20 questions, not 20 minutes. Where would 20 questions live in our table? Amanda.
Between 21 and 24.
20 goes in between these two? 20 is bigger than 21?
No, 18.
There you go. Good. 20 is somewhere between 18 and 21, which means our answer is somewhere in between what? 24 and 28. Work with your partner to use your number line diagram to find the answer. Okay, is 20 questions on the diagram? No. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Now, pay attention. You could make a big mistake and find 20 in the number of minutes, but the question doesn't say she had 20 minutes. It says she has 20 questions. Okay? So if 20 was in our table, where would it live? Leilani. Between 18 and 21. So what 2 numbers should I write on my top number line, which will be questions? Julia. 18 and 21. Well, let's break it up so we can find 20. Well, there's only 2 numbers in between 18 and 21, right? So 18, 19, 20. Here's 20. I'm going to circle it because that's what we know. And the number across from it is what we want. Now, how many minutes does it take her to finish 18 questions? 24 minutes. And how many minutes does it take her to finish 21 questions, Jordan?
28.
28 minutes. What do I need to do down here? Same thing we did up top, which is what, Jordan?
We need to find what is in the middle of both of those numbers.
What's in the middle?
Or in between.
Okay. Well, what did I do on top?
We found what's in between the numbers.
Mm-hmm. And that helped me divide it into how many parts?
3.
Yes, 3 equal parts. I have to do the exact same thing on the bottom. It doesn't matter what the numbers are. I have to do the exact same thing. So how many parts should the bottom be divided into? 3. Right now I have 2 unequal parts. I'm going to draw the same lines I drew on top. Now I have 3 equal parts. We got to figure out what goes here, right? So let's think of it as a tape diagram. If this is a tape diagram, what's it worth? What is the total? Javier?
The total is
Remember, what do we do here?
24 and 20.
Yeah, what do we do to find the total of this part right here on our number line? What is this? This is worth how many?
3.
No, not quite. It's 3 parts. It's in 3 parts. But what is it worth, Dewey? Tara? No! Mose? 4. Remember, 28 minus 24. That tells you the value of the area in between those 2 numbers. Okay? So we have a total of 4. We split it into how many parts? To find how much each part is worth, we would divide by 3, right? Okay, so I could say 4 divided by 3, but that would only give me how much this one part is worth. How many parts do I need? 2. I need to find the value of 2/3 of what number? Say it.
28.
2/3 of what?
20.
Oh, brother. Okay, pause. Pause. I'm hearing 2/3 of 28. Now, is our tape diagram worth 28 total? No. We have to pay attention to what we've drawn and what we've represented. I'm not taking 2/3 of 28. I'm taking 2/3 of this whole portion, which is worth 4. 2/3 of 4. Work it out. You have 10 seconds. At level 0. Okay. What's 2/3 of 4, Michaela? What? 2 1/3. How did you get there? Well, she started with, right? Yeah, 8/3. And is it 2 1/3? It's 2 2/3, right? Because 3 goes into 8 twice, and then we have 2 left over. 2 what? 2/3. So this whole portion, these 2 units, are worth 2 2/3. How do I find this number? The number of minutes it takes her to answer 20 questions. Rocco? How do I find this number? I know this part is worth 2 2/3, and we started with 24. So
I'm being weak, so I can't go by another. Actually, I don't know if this would work or not, but I was thinking we could probably wait, maybe add another, like,
okay, let me pause you. Let me pause. If this was a ruler, okay, and we started with 0, and I was counting up, and this said 2 2/3, this number would be 2 2/3. We're counting up by thirds, or 1 1/3 plus another 1 1/3 is 2 2/3. But we didn't start with 0, we started with 24. So what do I have to do? Tony? I need to figure out what number goes here. I know that between 24 and the number I want, I have a value of 2 2/3. So how can I find what number goes here, Kalia?
You add 2 2/3 to 24.
24 plus 2 2/3. And what do I get? Tony, go. What do I get, Michaela? 26 2/3. So what's this number?
26 2/3.
26 2/3. Sorry, that's tiny. 26 2/3. Kalia?
I actually did something a little bit extra. 2 2/3.
Yes, we're about to do that. We're about to do that. So, does it make sense? Do we talk like this when we're talking about minutes? If I say, it took me 26 2/3 minutes to do 20 problems. No, we don't really talk like that, right? How would we say something like that? Minutes and seconds. Minutes and seconds, right? So what's 2/3 of 1 minute? Leilani? What's 2/3 of 1 minute? How many seconds are in a minute?
40.
It would be 40, yes. So she says it's 40 seconds, but that's because 1 minute is 60 seconds. 1/3 is 20, so 2/3 is 40. I put 4. 40. So 26 minutes and how many seconds? 40 seconds. So it took her 26 minutes, 40 seconds to do her homework. Is that the answer?
Yes.
Nope. Look back at the problem. It says, how many minutes will she have left after completing her homework to talk to her friends? Okay, how many minutes will she have left? Well, what did she start with? What did she start with, Julie?
30 minutes.
She started with a half an hour, which is 30 minutes. She started with 30 minutes. And how much time did she spend?
26 minutes and 40 seconds.
So how much time does she have left? Talk to your neighbor. Work it out. Bring it back in 3, 2, level 0, and 1. Okay, raise your hand if you think it's more than 4 minutes. Raise your hand if you think it's less than 4 minutes. Jordan, what'd you get?
Well, I'm just guessing.
Okay, what'd you guess?
I guess, well, technically I guess 3 minutes.
Uh-huh. Okay, so 30 minus 26, oops, 30 minus 26 is 4, right? 4 minutes. Well, we still have to take away 40 seconds. So 4 minutes minus 40 seconds is what?
Still less than
4 minutes minus 40 seconds is 3 minutes and... Adriana?
I got 30.
No. 60 is 1 minute. Javier? 20. 3 minutes and 20 seconds she has left to talk to her friends. That's not a lot of time. Okay. Okay, so a double number line. Let's read this. A double number line is a representation of a ratio relationship using a pair of parallel number lines. One number line is drawn above the other, so the zeros of each number line are aligned directly with each other. Do we always write a 0 on both number lines? No, we don't have to. We can start with whatever value we need to. Each ratio in a ratio relationship is represented on the double number line by always plotting the first entry of the ratio on one of the number lines and the second entry on the other number line, so that the second entry is aligned with the first entry. Why do we do that? Why does the second entry always have to be aligned with the first entry? Why do the numbers on the two lines have to line up? Liliana. Do what? We need equal parts. What else? Association.
So that we can get the same amount per part?
Yeah, equal parts. Why else? Why is it important that I write the numbers directly across from each other? Let's look back at what we have. Why is this important that I wrote 18 here and 24 directly across from it, and then 21 and 28 directly across from each other, Kaylia? Yes, because we want to keep our ratios together, because these two ratios, 18 to 24 and 21 to 28, are equivalent. Exactly. So if I had written 28 down here and a different number here, they wouldn't line up and stay equivalent. So we line them up the way they're lined up in a table. We're just making number lines so we can split up the line and find numbers in between the values in our table. Davian? Question? Pencil? Go ahead.